Okay, so I'm going to make a couple of videos. The first one is going to be about absolute value equations, I think. So, a couple of things that you need to think about when you're solving an absolute value equation. So, the first thing, number one rule is you want to, I'm going to say, isolate the absolute value, which means that you need to get whatever is inside the absolute value all by itself on one side with everything else on the other. Okay. Once you do that, and you're going to do that sometimes by using inverse operations, right? You might have to add or subtract, multiply or divide. Once you do that, though, you are going to rewrite the absolute value equation that you have into two regular equations. And when I say regular equations, I mean that they have no absolute value symbols, right? The absolute values symbols go away. The first equation is whatever you had. The first equation is whatever you had. So I'm going to give an example. If I had the absolute value of 2x minus 4 equals 4x plus 6. The absolute value is already by itself, right? This is the only thing that is on the left side of the equal sign. So it's already isolated. So now I need to write two equations. My first equation is going to be 2x minus 4 equals 4x plus 6. My second equation is going to be 2x minus 4 equals the opposite of the quantity 4x plus 6. Why is it the opposite? Well, that's what I really want to talk to you about because I want to make sure you understand. So when I think about the absolute value, I'm thinking about how far it is away from 0. So if I have 3 plus x, so I am 3 plus x units away from 0. Well, that could also be taken in this direction, right? I could go to the left. So when you think about the absolute value of x equals a positive number, right? Well, what if I said, what's the absolute value of negative 3? The absolute value of negative 3 is 3, but the absolute value of positive 3 is also 3 because we have to work from both sides of 0. We have to work on the positive and the negative side. So when you think about solving an absolute value equation, the first thing that you need to realize is that you're going to write two equations with no absolute value signs. The first one is whatever you got with the absolute value isolated. The second one, the right side is going to be, or whatever side doesn't have the absolute value, is going to be the opposite of that. And then you're going to end up having to distribute that negative. So I'm going to look at this first example. I'm going to try and go nice and slow. So notice that in this first example, 1a, the absolute value is already all by itself on the left-hand side. So that's great. We're going to write two equations. The first one, no absolute value signs, 8 plus p equals 2p minus 3. My second equation, 8 plus p equals the opposite of the quantity 2p minus 3. It's the opposite. So I'm going to have to do some distributing. So let's solve the positive one first. Let's solve this equation number 1 first. So I could subtract p from both sides. 8 equals 1p minus 3, and then I could add 3 to both sides. So 11 equals P. Now I have to go and solve the second equation, because remember, there are two solutions to an absolute value. It can be the positive solution or the negative solution. Two solutions. It could be the positive one or the negative one. So the first thing I'm going to do is I'm going to need to distribute this negative, right? So 8 plus P equals, let's see, negative times 2P is negative 2P, and a negative times a negative 3 is a positive 3. So now I'm going to add 2P on both sides. So 8 plus 3P equals 3, and then I'm going to subtract 8 from both sides. And when I do that, I have 3P equals negative 5, divide both sides by 3, which means P equals a negative 5/3. P equals a negative 5/3. Okay. All right. So let's go to example B. So remember, the first thing that I said is if we're going to solve an absolute value equation, the first thing that we have to do is get the absolute value bars, that symbol. We have to get this all by itself. So the first thing that I'm going to have to do is I'm going to have to get rid of this plus 5. If I had 2x plus 5 equals 9, you would get rid of the 5 before you start undoing the multiplication, right? So same kind of idea. We're going to get rid of that 5. So the opposite of a positive 5 is a negative 5. I have to cancel it out. Okay, so now I have 4 times the absolute value of 2y minus 7 equals, let's see, 9 minus 5 is 4. Now this says 4 times the absolute value. The only way to get rid of that is to undo multiply, and the undo of multiply is divide. So now I have the absolute value of 2y minus 7 equals, let's see, 4 divided by 4 is 1. So the only thing that I have on the left side of the equation is the absolute value sign. So the absolute value is isolated. So now I'm going to stop and I'm going to write two equations. One with the exact equation that I have, 2y minus 7 equals 1. The second one, 2y minus 7 equals the opposite of 1. So 2y minus 7 equals 1. And my second equation, 2y minus 7 equals the opposite of 1. All right, so I'm going to add 7 to both sides. 2y equals 8. Divide both sides by 2. So y equals 4. That's my first solution. My second solution, when I add 7 to both sides, I get 2y equals 6. Divide both sides by 2. Y equals 3. So those are my two solutions for example B. The two solutions are 4 and 3. Remember, this has two solutions, right? Okay. Let's look at example C. So notice that these are getting harder every single time. So the first thing I'm going to do is I'm going to divide my equation, draw my river, split the equal sign, right? So I'm trying to get the absolute value all by itself. The first thing that I have to do is move away this positive 4. I have to move away the positive 4 because this negative 8 is actually attached to the absolute value with multiplication. This negative 8 is actually attached. It says 4 minus 8 times. So 8 is being multiplied minus 8 times. So we're going to get rid of this 4 first. So I'm going to subtract 4 from both sides. Okay. So let's see. That gives me negative 8 times the absolute value of 3x plus 2. And that equals negative 24. Okay. So now I have this negative 8 times absolute value of 3x plus 2. I have to undo multiply. You undo multiply by divide, which is a good thing. So I know that I need to have a positive answer over here. So now I have the absolute value of 3x plus 2 equals a negative divided by a negative is a positive, because I know that the solution to an absolute value equation has got to be a positive answer. Okay, so I've got the absolute value isolated. It's all by itself. So now I'm going to write my two equations. The first one, 3x plus 2 equals 3. The second one, 3x plus 2 equals the opposite of 3, right? So I have to go on both sides. So I'm going to subtract 2. 3x equals 3 minus 2 is 1. Divide both sides by 3. So x equals 1/3. That's my first solution. My second solution, let's see, my second solution, when I subtract 2 from both sides, I get 3x equals a negative 5. Divide both sides by 3. X equals a negative 5/3. That's the second time we've had an answer of negative 5/3, I think. So that is kind of like the steps, not kind of, it really is the steps for solving absolute value equations. So you want to get the absolute value sign all by itself using inverse operations, and then you want to stop and rewrite two equations without the absolute value signs. The first one is whatever it is. The second one equals the absolute value equals the opposite of whatever. Okay. All right. So now let's do some talking about solving and graphing absolute value inequality. So there's something I'm going to write over here. I'm going to write less than. So, sorry, that's not less than. I apologize. So less than. Anytime you see the less than or the less than or equal to, this is how I say that when I'm doing absolute value inequalities. I'm thinking of it as less than, and that's got an and in it. Okay. And then when I see the greater symbol, if something is greater than or equal to, I think of it as a great or. A great or. So the first thing that I want to do, kind of the same idea, same exact idea. You're going to solve the absolute value inequality by isolating the absolute value sign. So I have to get this all by itself on this side of the inequality. And I have to remember rules that apply to inequalities, right? So the first thing that I'm going to do is I'm going to add 4 to both sides. Add 4 to both sides. So that gives me negative 2 times the absolute value of x plus 3 is greater than or equal to, let's see, negative 2 plus 4 is a positive 2. The next thing that I need to do is I need to divide both sides by negative 2. And that makes me think about an absolute value, about an inequality rule. So this is an inequality rule, right? It's really important. It says when you multiply or divide by a negative, you have to flip the inequality sign. Okay, that's important. That's a rule, right? That is something that you learned definitely 8th grade freshman year. So now I'm flipping the inequality sign. So negative 2 divided by negative 2 is a positive 1. So I just have the absolute value of x plus 3 is less than or equal to negative 1. Is less than or equal to negative 1. So this is an and. This is an and. So this means that when I write my two equations, I have x plus 3 is less than or equal to -1, and x plus 3 is greater than or equal to +1. So let's talk about what we did. We wrote the first equation just exactly like it was written without the absolute value signs. Okay. But when I come up with my second inequality, I have to make it the opposite. The opposite of a -1 is a +1, but I have to flip my sign. I have to flip my sign. So now we're going to solve these. So I'm going to subtract 3 from both sides. So this means that x is less than or equal to -4. And when I subtract 3 over here, sorry, I got ahead of myself, x is greater than or equal to -2. So when you have an and, the solutions shade together. The solutions shade together. So let me show you what I mean. So I'm going to put -4. I'm going to put -2. X is less than or equal to -4. And x is greater than or equal to -2. Well, when you have an and, right, it's supposed to be both. Both solutions are supposed to overlap. Do you see how that's not happening? That is not happening. So that means that there is no solution. And I'm going to show you why there's no solution. I'm going to go back to the original absolute value before I split it into two equations. The absolute value of x plus 3 is less than or equal to -1. So I want you to think about all of the numbers that can be less than or equal to -1. Well, -5, -3, -2, -1. And I know that there's a ton more, right? There's a ton more. But I also know that the answer to an absolute value equation or inequality must be positive, right? It must be positive. And the only way that this would be true is if the symbol were facing the other way, were greater than. And it's not greater than, it's less than. The only kind of numbers that are going to be less than -1 are negative numbers, right? Negative numbers are less than -1. And you cannot have an absolute value. You cannot have an absolute value equal to a negative number or less. It can be equal to a negative number or more, right? Greater than some specific negative if you're doing inequalities, but it can't be less than -1. So that's really why there's no solution. But we went ahead and practiced the whole idea of an and. So let's try number 2, see how we're doing with it. We're going to, or number 3, sorry. Let's try number 3. So remember, I'm trying to get the absolute value by itself. Okay, so I see that I have to get rid of this +5. And the opposite of a +5 is a -5. Okay, so I have the absolute value of 3p minus 5 is less than or equal to, let's see, 9 minus 5 is 4. Okay, so now I have the absolute value all by itself. I'm going to have to write two inequalities. Two inequalities. The first one is just this absolute value inequality without the symbols, without the absolute value bars. 3p minus 5 is less than or equal to 4. The next one has to be the opposite of 4 and flip the sign. 3p minus 5 is greater than or equal to -4. So now let's solve each one of these inequalities. I'm going to add 5 to both sides. 3p is less than or equal to 4 plus 5 is 9. Divide both sides by 3. P is less than or equal to 3. This is a less than, right? So this is another and, less than, right? So and when I add 5 to both sides, 3P is greater than or equal to negative 4 plus 5 is 1. Divide both sides by 3. P is greater than or equal to 1/3. All right, so I'm going to go to my number line, and I'm only going to put the two numbers that we're talking about on my number line. So I'm talking about the number 1/3, and I'm talking about the number 3. For the number 1/3, P is greater than or equal to 1/3. So it's going to be a closed circle, and I'm going to shade above everything that's to the right of the 1/3. But the other inequality, P is less than or equal to 3. So closed circle on my 3. And I'm going to shade everything that's less than. And notice how the two solutions overlap. They're kind of nestled together. This is what an and looks like. Okay? So those are my two solutions. Those are my two solutions. All right. Let's do number 4. So number 4, the first thing I'm going to do is split my inequality. I'm going to subtract 1 from both sides. So this gives me the absolute value of 2x minus 1 is greater than negative 1. So, whoops, I forgot to put my other absolute value. So this absolute value solution is going to be greater than negative 1. So numbers that are greater than negative 1 end up being positive eventually, right? So we're going to have some positive numbers. So that's why this has a solution. This one has a solution. And because it's the greater than symbol, it's going to be an or. It's going to be an or solution. So I want to tell you that ors go in opposite directions. You have one that goes this way. You have one that goes that way. It's either, here's how we read an or. It's either this or that. That's what it means when you have an or. Okay. Whereas an and means both are true. This and that. And that's why it overlaps. That's why the solution set overlaps in that red. Okay. So we have our absolute value isolated. Let's go ahead and rewrite our two inequalities. So our first one, 2x minus 1 is greater than negative 1. Our second one, so we're going to flip the sign, less than, opposite of negative 1 is positive 1. So 2x minus 1 is less than, opposite of negative 1 is positive 1. So let's see, I'm going to add 1 to both sides. 2x is greater than 0. Divide both sides by 2. X is greater than 0. My second inequality, I'm going to add 1 to both sides. 2x is less than 2. Divide both sides by 2. X is less than 1. X is less than 1. So let's look at what happens. This is 0. X is greater than 0. So that's going to be anything that goes this way. X is less than 1. So here's a 1, open circle. That's anything that goes this way. So you notice, whoops, half my line disappeared. That's what happens. So hopefully you notice that when these overlap, I'm not sure what's going on. My entire number line is going to be colored in. This means that this has infinitely many solutions. This is a special case, which means any number works. Any number works, right? You can choose a number that's less than 0, like negative 4, and plug it in. I'm going to check it just to show you. So if I let x equal -4, I have the absolute value of 2x is -4 minus 1 plus 1 is greater than 0. So this is just me showing you that I'm going to let x equal -4 and it's going to work. Let's see, 2 times -4 is -8. -8 minus 1 is -9. Well, the absolute value of -9 is +9. And +9 plus 1 is greater than 0. What if I choose some really big number that's greater than 1, like 100? What if I let x equal 100? Well, let's check that, okay? So let's see, that's the absolute value of 2 times 100 minus 1 in the absolute value symbols plus 1 has to be greater than 0. Well, 2 times 100 is 200 minus 1. That's 199. The absolute value of 199 is 199. And 199 plus 1 is 200, and 200 is greater than 0. Okay? So any number will work. This is infinitely many solutions. I'm going to stop for a second and pull up a worksheet that has some more absolute value inequalities, and we'll do some practice with absolute value equations and inequalities.